Hello. Guess I'm streaming. I'm never sure if it really starts to record from when I press the stream button or there's only the delay here. But okay. So last time I stopped at the chapter 5, and in the meantime I was looking at more kind of examples in C. Since this book is well, that's the thing with books. They kind of give you one example or two examples, and then they explain with many words the example kind of a thing. And what really lacks, what I guess what's up to the reader is to do many little types of etudes. I'm using a musical term, etudes, but a little kinds of subset of examples that belong to that example. So I've been using Chat GPT also a bit to generate so kinds of practice like examples that would show me a bit, like for example malloc. So so I'm trying to see what does that actually mean. And there was a comment, on the channel, and I'm gonna read it. Yeah, I like how you configured your setup like Zoding. Yes, it's true. He kind of, well, I've been changing my setup since like 209. So 2009. And but lately it was kind of inspiring to see Zoding, and he kind of helped me to be well, he kind of sparked something. So I kind of like this setup also. It's nice. It's i3 with Void Linux, although I was on NixOS for like 4 years and I still kind of jump back and forth. I may come back to NixOS too, because the funny thing is he was also on NixOS before he quit for Debian, I think, and then he went to Void. And it's not that Void has any kind of, I don't know, because after NixOS, it's really every other distribution is just another distribution, I guess. It just depends. Some things are not so hard, some things are hard. Like maybe Ubuntu is more out of the box and Void Linux is not so out of the box, but in the sense it's not so hard also, and you can quickly get really, with Void you can really install everything very quickly, and it just works. So I don't know. I'll kind of see. But yeah, he has a nice setup. So the comment here is, so what the line char star cpy equals malloc sterlen buffer plus 1 is doing is dynamically allocating as much memory is needed to store the string stored in buffer into CPY. Malloc is a C function that is used to dynamically allocate memory on the heap. Now, it has a void return type, meaning you can assign it to char pointers, int pointers, float pointers, etc. Now, I understand what's written here, but again, there's all of these meanings which I don't. But I was kind of rethinking my attitude towards this C kind of imperative programming, and coming from kind of a functional mindset. I think, I'm just trying to blend these two worlds and not to see, not to say why malloc, why memory and such. So I'm kind of getting lost in words now. But yeah, I guess here it's, you could say what you want your program to do, but it's like with C, I have to also, in some sense, with C, there is maybe more communication with the machine. I was saying before that functional programming is very communicative in the sense that you're saying what you want and not just saying, as I wrote, like a big boss, I want this, I want that. But now I'm seeing it. This is actually being nice to computer. It's not just saying, I want you to print this, but it's like, I want you to print this, but could you please, or like first saying, could you please make some space? Like, could I print something? And could you create these kinds of space? Do you have space? And make me a space so that I can do something. And then when I do that, I will clean up everything, you know? It's like I do what I want and thank you, you know, computer. And then when I do that, I will return whatever I have done and clean up the mess and clean up so that you have again everything nice. So in some sense, it's like more interacting with the computer. And so yeah, I guess all of these words kind of describe that. So instead, you see what the line char CPY, so char star is a string. So I guess we're going to print something, but we're going to create some kind of a space on the heap. Now I've been looking what's heap and what's stack, but basically heap is kind of more, yeah, I can't explain now but stack and heap there is a yeah, it has a void return type, meaning you can assign it to char, pointers, int, pointers, float. Strlen is a function that finds the length of a given char array. I guess heap is something like, yeah, I don't know, like in simple terms, what's the difference between the heap and the stack? You know, because I understood stack is more like physical, you know, and heap is from heap. Wait, yeah, the heap and the stack are two areas of memory used by your program, but they serve different purposes and work in different ways. So the stack is used for temporary short-term memory, like variables in functions. Variables in functions. I guess this has to do with scope. Like, I guess if I want to declare, I think if I want to declare a global like variable, it will be saved on the heap because it is supposed to be available throughout the entire evaluation, or how do you say, of the program. So memory is automatically allocated and de-allocated when functions are called and returned. So it's very fast and organized like a stack of plates, last in and first out. So limited in size, usually a few megabytes. Is this really always? Examples: when you declare variables like int x is 5 in a functions, x is stored on the stack. And when the function finishes, the memory for x is automatically reclaimed. So I guess also when we just print something, when we had that lifetime, memory lasts only as long as the function is running. So int x is 5, print x. So I guess that would be the same thing, right? Memory lasts only as long as the function is running. And the heap is used for long-term dynamic memory, where you can request memory that stays around until you explicitly free it. So it's almost like, yeah, it's like a long-term memory that you save or like write into somewhere and keep it. And then when you need it, you go and check the heap. Oh, that's the information I need, how it works. So memory is allocated using functions like malloc and must be manually freed with free. So that's the interesting thing. That's what I was saying. Like, it's kind of nice in the sense you're trying to be polite with the computer because you have to also manually free it. It's almost like cleanup after yourself. It's slower than the stack because the system has to search for a free block of memory. Oh, I see. It's slower than the stack. Much larger than the stack, can be gigabytes. When you use malloc 100, you're reserving 100 bytes of memory on the heap. That memory is available even after the function that allocated it has finished. Memory stays allocated until you explicitly free it with free. So you have to free it. All right. Very fast, slower. Lifetime. Temporary ends with function. Permanent until free is called. Is that the reason why we give the return smaller, larger, automatically by the system, stack, and heap manually by the programmer? And yes, stack is for local vars and function call, and heap is for dynamic data like strings or arrays. That's what we did in the, I think in our first REPL, we defined that static char star and like a buffer of size 2048. That was an array, I guess, that was defined on the heap, right? So if we go to our, wait a second, code build REPL. So did we define it? Yeah, static char buffer, right? Static char buffer. And static char buffer. Right, so that's on the heap. Do we free it back? While free input, free retrieved input. We do, we free it. Right, so this was defined on the heap. And then we free it. And the size of it is 20, but we didn't use malloc or something, right? Static char buffer. Static char buffer 2048. Think of a stack as your desk while you're working. All right. I like this. ChatGPT is good with analogies. It works. Think of a stack as your desk while you're working. You quickly put things down, declare variables, and pick them up when you're done. Function ends. Space is limited, but it's fast and easy to manage. That's nice. I kind of like that. That's what I have here on this table or on this piano. My computer is at a piano. And think of the heap as a filing cabinet. You open it and store something, allocate memory when you don't have room on your desk or need it for later. You have lots of space, but it's slower to access, and you must remember to clean it out, free memory when you're done. That kind of makes sense, yeah. When to use each. So use the stack for variables whose size you know at compile time. Data that only needs to exist while the function is running. So I guess that's the thing with scope, right? I guess the problem is sometimes if the problem, I guess it's not a problem, but complexity comes when your function is calling another function is calling another function, and you have variables. I guess you have to put them on the heap, but maybe you could overflow the buffer. Buffer, yeah. I guess that I've heard that expression. So use the heap for larger dynamic data like arrays whose size isn't known until runtime. Data that needs to persist after a function ends. So we had static char buffer 2048. So why did we, when I declared static char buffer, wait a second, is this static char? I don't have a star. Buffer 2048. When I declared, and then later had free input. Okay, how come we didn't use malloc. The key difference lies in how memory is allocated and managed for static arrays like buffer and dynamically allocated memory like input. Static char buffer, stack allocation. When you declare static char buffer, the memory for the array is allocated on the stack. Oh, it's not on the heap. Or sometimes the data segment, depending on the use of static. Static char buffer. Because it's static. Is it because it's static? So this allocation is automatic and the program takes care of it. You don't need to use malloc because the memory size is already fixed and allocated at compile time. I see. Lifetime of the buffer. Since the array is static, it has a fixed size of 2048 bytes and exists for the entire lifetime of the program. Static variables are stored in a special area of memory, data, or BSS segment rather than on the stack, ensuring they persist across function calls. No need for free. I see. Well, it's interesting, definitely. So, but fake readline function. We see we have this also. We have malloc here, strlen buffer. We have a fake readline function, char star cpy. So cpy is the name of that space on the heap. Okay. Let me check again the. Let me check again. I guess the comment. Oh, my CPU. So what the line char star cpy malloc strlen buffer +1 is dynamically allocating as much memory is needed to store the string stored in buffer into cpy. The string stored in buffer. So the string stored in buffer, right? This string that's stored here in buffer. To store the string stored in buffer into cpy. So we are storing a string in buffer and then into cpy. So we are storing the string in buffer and then into cpy. So we are storing the string into a buffer on the stack and then storing that buffer into cpy with malloc on the heap. But why are we doing that? Exactly, you've got it. Here's a breakdown of what's happening step by step. So storing the string into a buffer. Yeah, I kind of got a bit of, negative vibes with using ChatGPT, but someone said they should ban the site. Although they were some of the good points, but I kind of use ChatGPT for everything. Like I could make a whole stream now about how I use ChatGPT, not just for programming, also for life stuff, and even it's saved my job even, that's a whole, different thing. It saved my job and it helped one of my friends who had a drug related kind of, well, I don't know if it's drug, but it had some kind of a mental problem. And and then when I was talking to my friend, I realized I may say the wrong thing. So I was copy pasting what the friend wrote to me into ChatGPT and kind of reflecting what, ChatGPT said. And then I reframed my words. And later, my friend did not know that, but later, at the end, and you can see it. Okay, this is much better than what I would write, even though of course you cannot go too far and you have to be smart, but also you have to practice with it. You practice with Chat, GPT, and okay, I'm now going into a rant with ChatGPT, but the thing which is nice and which is kind of changing the way we learn, instead of learning everything, and here is like you reflect on what's given back to you, and it's kind of reshaping the conclusion or the answer, right? So you get it back and then you reshape it, you talk to it, and yeah. Well, let me get back to this. Storing the string into the buffer on the stack or data segment. So when you use something like static char buffer 2048 or just char buffer 2048, yeah, I saw this too, and I saw also this. So there is a difference between the static. What happens? So the string is being stored in the fixed size buffer array. Is a fixed size buffer array depending on how buffer is declared. If it's static char buffer, the memory is allocated in the data segment, persist for the entire lifetime. Just a moment. Depending on how buffer is declared, if it's static char buffer, the memory is allocated in the data segment, persists for the entire program lifetime. If it's char buffer, the memory is allocated on the stack, temporary and tied to the function scope. Yeah, but I thought char buffer is global and kind of tied to main, right? It's tied to what function? Why use the buffer? The buffer is a convenient and fast place to temporarily store data, especially when working with fixed sizes or when the data doesn't need to persist for long. Persist for the entire program lifetime. So I guess static is global and char is not. Copying the buffer to CPY on the heap. So this is what the comment was saying. So later you use malloc for dynamically allocate memory for CPY. Char star CPY, malloc strlen, well, that's basically string length. Buffer plus 1. And memory allocation. So malloc allocates a block of memory on the heap large enough to hold a string in buffer, including the null terminator /o \0. The heap memory is separated from the stack memory. And then copying the string. You copy the contents of buffer into CPY. Oh, I see. Char star CPY malloc strlen buffer plus 1 string copy. Then we copy the string into CPY and buffer. Because string copy is a function that as its arguments takes a copy and a buffer, right? But here is written copy strlen copy -1 return copy. Fake readline function. Yeah, this kind of, I still don't get it, this function. So you copy the contents of buffer into CPY. Copying the string, you copy the contents of buffer into CPY. Now CPY holds its own independent copy of the string. Why use malloc? To make the string persistent. Unlike the buffer, which may go out of scope when the function ends, CPY is stored on the heap and will persist until you explicitly free it. The size of the buffer is fixed, but using malloc you allocate just enough memory for the actual string, which is more efficient. So there are a lot of concepts here. Look at this, key takeaways. So what I usually do, look at this, fake readline function. How do you copy from Emacs? I don't even know now that. Wait a second. How do you copy a block of code from Emacs to here? Gosh, no, that's. I've just changed back to it, so I kind of don't know. Select the code, Control Space. I'll press Control Space to set the mark and move the cursor to the end of the block code using the selected region should now be highlighted, and press Meta W to copy the selected region to the clipboard. Really? Control Space. Like this. Or like this. Then Meta V. Like this. And paste the code here. Okay, really? It will paste? All right, it did. So, okay, we have here a fake readline function, right? This is what I kind of like to do with Chat GPT. Wait a second. Let's lay, okay. Right. So here we have a fake readline function from our REPL.c. Now I still don't understand. I'm using more ChatGPT now because there's no one on the chat. I guess there's no one on the chat. Now I still don't understand. We have fake readline. So now, can you create a small example of sort using just like a hello kind of world program where we allocate a small amount of memory, or maybe like let's create a hello world program for malloc function and then expand it to a malloc and strlen function, something like that, because this readline example is too complex. I'm looking more into a etude-like example that will be short and simple, and then build on that until we get to the readline example. This is something, yeah, let's see. Because it's one of the things with these books, like you get this example and a description, and that's it. What ChatGPT can help, he can actually generate smaller kinds of examples if you give it this, and that kind of gives a little bit more context. So but it needs practice. So you see this output. So let's create an incremental set, an incremental set of examples starting with a simple use of malloc and building towards a readline-like function. These examples will focus on understanding how malloc and strlen work step by step. The simplest malloc example. And also I was recommended to see CPP reference and to check malloc. If you go to CPP reference, void malloc size t size defined in header standard lib, allocate size bytes of uninitialized storage. If allocation succeeds, returns a pointer that is suitably aligned for any object with fundamental alignment. Malloc is thread safe. Parameters example code. There's an example code. Include studio, include stdlib. Int main void, int p1, malloc 4 size of int, allocates enough for an array of 4 int. Same, naming the type directly. Same without repeating the type name. If p1 populate the array, print it back, free P1, P2, P3. I kind of get what this means, but it's, yeah, I guess it needs, you know, more practice and examples. Let's see what Chad said. The simplest malloc example. He's doing like this. Yeah, let's see what they did, and then I'll get back to, you know, reading the book, because sometimes the rabbit holes tend to be, you know, just rabbit holes. We'll start by allocating a small amount of memory with malloc, storing a string in it manually, and then printing the string. This is what I wanted to do. Include studio, include standard lib. So it says that malloc is defined in standard lib.h. Okay. That's why we need also standard lib.h. So I don't know, I'll just try this out. Let's save this. Build your own Lisp. Malloc C. Malloc C. Wait a second. Malloc C. So we're gonna have a include standard io.h and include standard lib.h. Right. So now we have an int main, and wait, I should put the electric pair mode. All right. We have an int main, right? And the int main return O, print message. So maybe we could write it like, so we will have a, let's try to do it like int main, and we will have return 0, and we will want to have printf, right? Some kind of a string, and will that be saved in a var, in a variable? It will be called message, right? So it will be called message. And so we have a int main, and then the body is printf s, and then a message, return 0. What is the message? The message, we have to declare it somewhere. Allocate memory for a string. Example, 6 characters for hello. Hello. Just H-E-H-E-L-L-O. That's 5 characters. Why 6? 1, 2, 3, 4, 5, 6. The null terminator to make it a proper string. Oh, I see. That's why 6. All right. This is kind of a fun. This is fun. Yeah. So we're gonna have a char. So we're gonna do char message, char star message, and is malloc 6. I guess we have to do a bracket because it's an array. It's an array. All right, return 0. And we should also free the message, right? At the end, we will have to free the message, return the memory, right, that we allocated. Although it's written at step 4, I think it looks nice like this because it kind of makes conceptual sense. I don't know, is that the right word? So free message. I have to do something with indents here. It's kind of weird. It looks weird. So what do we have here? Let's do it like, yeah. So we have an int main, and we will define char star message. I mean, you know what's actually, when we were defining the buffer The star was on the side, on this side, not on the char, right? Right. Step 2, use malloc. Wait a second. Let's stick with the step 1, okay? And wait for me until I understand, because I will have more questions about the step 1. Like you put a star next to char, like char star. And in other example, I saw something like char, but the star was next to the next word, like char star message. What's the difference? So now we are checking why the star is you see this? I saw this, like there is sometimes char star something and sometimes char star something. The difference between char star message and char star message is purely stylistic. What do you mean? They mean the exact same thing? What does the star mean in char star or char star? The star indicates that the variable is a pointer to a char. A pointer is a variable that stores the memory address of another variable. Char star message, right? That means message is a pointer to a char, or the first character of a string. Someone said in one of the YouTube actually comments that with pointers it helps to read it backwards. So you read it backwards in the sense that you read it from right to left, not from left to right. So like a message is a pointer to a char, right? Even though you write char star message. So the star is always associated with the variable being declared. Char star message, others prefer this style because it emphasizes that the pointer is part of the variable being declared. It reads as message is a variable of type pointer to char. And this reads as message is a pointer to a char. Oh, I didn't know this. So it's kind of a style kind of a thing. No functional difference. All right. So you see, now you get lost. Wait a second, this was step 4. No, let's get back to step 1. Let's get back to step 1 again. Let's look at our program. So int main char star message malloc6 printf message free message. Will this work? Can we print the wait? So this was if message null printf memory allocation failed. Okay, this is just to check if the thing will succeed. Let's see if we can fill it. We have to actually fill it. Maybe it can print a letter, not, wait a second. Let's do like malloc 1, malloc 2. So we'll have a number. Let it print a number. Can it print a number? And let's do it, you know, char, or let's write, let it print a letter. Yeah. So maybe like do message. Okay, let's keep the message. And the char star message will be malloc 2. And manually fill the memory with a string. So we have to like manually fill it. So with, actually we have to call message. Message 0, right? 0. And that's what? That will be a letter that we wanted to print. So let's print H. And let's close that and message 1. Now if I write 2, will that? if malloc 6 was 0, 1, 2, 3, I guess this would be malloc 2 and message 1, yeah, is, and will this be this kind of, yeah, null terminator to make it a proper string, right? Ah, no, what am I doing? That's so weird. Yeah, it's here. All right. So we have char star message, malloc2, message 01, HO, printf sn message. Well, I guess we can print a letter as a string or not. Maybe yes, because we have 2 characters. Message. Will this thing, let's see if this thing actually will compile. So this is called malloc C. Can we save it under a different find? No, we cannot. Let's see. Let's split this. vterm. I'm going to open up a terminal in Emacs. Let's, okay. So now we're gonna GCC, what do you mean, dash wall dash o malloc dot c free message. So it didn't work. Error expected before free. Oh, printf needs this, right? Let's see again. Will it work? No. Subscribed value is neither array nor pointer nor vector. malloc scene function may malloc c subscripted value is neither array nor pointer nor vector. Char message. Interesting. malloc. So maybe I should check if the program actually compiles, because that can happen with ChatGPT. If message null, printf memory location failed, char message malloc 6. Free message. Standard lib. I guess we can try it and then see. So we will have to do message 02. Let's do a hell message, that's 3. Hell, is it again? Hello, yeah. Hello, and then message 4. Hello. Hello. Like this. And message 5 is the null terminator. Char message. Hello. malloc is a function, not an array. So right, so is the code... Oh, that's the mistake I was doing. Because I wrote it as an array. It was here is the thank you. Hi, thank you. I'm just trying to make it like a simple hello kind of a world for malloc. So maybe I could now delete this. Message 1, now I put the 0. Will it now work? It does work. H, you have to tell it that malloc is a pointer. Also, it has to be long as the message. Yeah, right? So this works now. Yeah, I was trying to make, I'm like, you have to tell it that malloc is a pointer. Also, it has to be long as the message. Yeah. No, because I put brackets here. which was wrong. I did that when I had like static char buffer, and then I defined an array that was on the stack. So now I wanted to see how malloc works, and now it's not with a brackets, but it's with parentheses. So that's the difference. Printf message, and it printed H. I guess this is a very simple example, right? I mean, it's not like you, yeah, manually. That's how I use malloc for char. But also, is that a style kind of a thing? I don't know if you heard this from before. Sometimes I see star next to char, and sometimes will be char and then star will be next to message. Now ChatGPT says int malloc and times size of int. Oh, I see this. You declare the size. Ah, yeah. I think I had this in the example. What did I have in the example REPL? This is what I have in the example that I'm trying to understand. This. No, I have this actually. Static char buffer, and then that buffer is basically copied. You see this line here. Char is always size of 1. Char is always size of 1. Char is, so for char type we don't need is size of. You're doing it with int here. Oh, you're doing it with int. Yeah, I kind of get what you're saying, but yeah, that's a little too advanced still. So this is the function that I was trying to understand, this line here. But yeah, so I wanted to, yeah, I don't know how far you've been here with the stream. Well, I kind of understand a bit how it works. I guess I should move on because, yeah, I think I need some more practical example where I would need this. Just doing, malloc and going back and forth and defining space. I think it's kind of, yeah, I need a more practical example for this. So, right, manually fill the memory with a string. What's happening step by step? Yeah, ask the system to allocate 6 bytes of memory on the heap. Returns a pointer. Check if allocation succeeded. Memory, okay, I didn't put the check though. Yeah, there is a check if it failed. Fill the memory, print the string, free the memory. This releases the memory. If you don't call free, your program will leak memory, meaning it will use up memory without giving it back. I see. Memory layout. Oh, here's how memory looks at each step. A 6-byte block allocated on the heap. In the beginning, I used char star var, but I ended up using char star var after seeing so many code using this style. I see. Yeah, but I guess it also depends how you read it. I saw a comment where they read it from right to left. I don't know if that will change how you read it, if you change the position of the star. After filling the memory, we manually store hello. After free message, yeah, well, this is kind of, yeah, okay, this is simple. Questions you might have. Why do we need the null? Yeah, where the string ends. You can modify the program to allocate more memory for a longer string. Well, we could do that, but that's kind of not hard now. We just add allocate more memory. Yeah, use a loop to fill the memory instead of assigning manually. It's just a preference, but in C world, char star var seems to be the majority. All right, thanks for that. So use a loop to fill the memory instead of assigning characters manually. Yeah, I don't know how to do that. That would be, I guess, how do you, I forgot. I think CXO. No, CX. Yeah, I forgot in Emacs. How do I go through buffers? Wait a second. CG. Ah, gosh. Wait a second. I forgot. How do I go through buffers in Emacs? Listed. Where do I switch between CXB? CXB. Yeah. CXB. No, CXJ, CXB. Switch to buffer malloc.c. Yeah, now it's here. Try mallocing a few gigs of memory. You will be able to see it in the task manager. Oh, that's kind of cool. And you mean, then I should name it, somehow, and then I will see it by that name. You're able to see it in the task manager. Will my stream crash? But wait a second, char star. Okay, but now I was doing it manually. I could do it with a loop. Could I do it with a loop and do it like 1 gig? Are you? No, I'm on Linux. I'm on Linux. So maybe I could do it with a loop. I don't know how to do it with a loop. Sadly I am. How do I do it with a loop? Char message, malloc. Yeah, you see, I've learned about loops last time, but I have no idea how to put this in a loop. Twitch Jordan. Oh, thanks for the follow. Me too. Garuda. Yeah, I know Garuda. I'm on Void Linux. But yeah, why do you want to use a loop? Just to practice, I guess, because I don't know. Could I do like a loop? Because now I was actually manually, how do you say? Like I defined a space. Yeah, I don't know. Why would I use a loop? So instead of printing each letter, I guess it will be just to print. Yeah, I'm not sure now. Yeah, now when you say why do you want to use a loop, I'm not sure. I guess just practice loops because they've been a helpful. Yeah, close a buffer. Why do I want to use a loop? I don't know. Yeah. Well, anyway. Yeah, I guess that's enough for malloc now. Sure, yeah, you need to do all these little examples, like you said. It would be cool to see it in the memory, but how would I allocate to malloc a gig of memory so that I can see it with htop? Yeah, I'm not sure. How would I allocate? Memory is straightforward, but keep in mind that modern use a virtual memory. This means the memory may not appear as fully resident in htop unless it's actually accessed. I have to use this thing. Size T gigabyte. I'm still green on C, but I've started solving some challenges in exorcism. Yeah, I should check that actually. I was also trying to find some kind of, things. Wait a second. This was a comment. Data structures. I found this also. This is kind of cool. Look at this. This is notes on data structures and programming techniques from Yale. And it's all about C. This is kind of cool. I don't know. I guess you could check that out too also. This thing, these are actually, I found this link on Reddit. It's a lot. It's all on C. And these notes are kind of nice also. Look. Yeah. I'm gonna check this also. Yeah. Um, okay, I'll just go on with the book now. 1056. So, what is a programming language? A programming language is a very similar to a real language. There is a structure behind it and some rules which dictate what is and isn't a valid thing to say. When we read and write natural language, we are unconsciously learning these rules, and the same is true for programming languages. We can utilize these rules to understand others and generate our own speech or code. In the 1950s, the linguist Noam Chomsky formalized a number of important observations about languages. Many of these form the basis of our understanding of languages today. One of these was the observation that natural languages are built up of recursive and repeated substructures. Do you know other code languages? Yeah, I've been learning kind of, I know Nix. I was on Nixos for a couple of years. And or are you guys talking in between? Maybe, yeah, but I'm coming more from functional programming languages, so I'm kind of very new to this imperative style of thinking. As an example of this, we can examine the phrase "the cat walked on the carpet." Using the rules of English, the noun cat can be replaced by two nouns separated by and. The cat and dog walked on the carpet. Each of these new nouns could in turn be replaced again. We could use the same rule as before and replace cat with two new nouns joined with and. Or we could use a different rule and replace each of the nouns with an adjective and a noun and add description to them. Yeah, he talks here about... I read this already before the stream. And this chapter is more like just, he talks about languages and how they build up like this. If x is greater than 5, return x. And then if x is greater than 5, and then inside we can repeat if x is greater than 10, return x. So if x is greater than 10, return x. And then we check if x is greater than 5, yes, return x. So it works inside out. Not used to functional. Yeah, I am used, so it's still weird with loops. Like I don't know, I is 1 and then I plus plus. So it's like, it's weird for me. Well, most I know is higher order functions. We can describe rewrite rules. So in Build Your Own Lisp, he's going to use the MPC library. And this was one of the critiques of the book because it was not like written from scratch, the parser combinator library, but he's going to implement it at the end of the book. His idea was that it was maybe too complicated for now to implement the MPC and then to continue building the Lisp. So yeah, I guess that's okay. I don't know. MPC is a parser combinator library I have written. Many parser combinator libraries actually work by letting you write normal code, a bit like a grammar, not by actually specifying a grammar directly. Okay, coding grammars. So here there will be some examples, and I would like to use C to write this. This will be cool, and then maybe build a random generator of sort that will make combinations of adjectives and nouns and create random like sentences. That would be kind of something what I could do to practice writing C. And then maybe then that could be actually put into a heap with malloc. And in that way to combine even the string length with malloc and generating random sentences. Maybe, yeah. An adjective is either wow, many, so, or such. A noun is either Lisp, language, C, book, or build. A phrase is an adjective followed by a noun. I don't know, a doge or dodge is a zero or more phrases. So I think the first time when you read it, like this is very functional. So a doge is actually all of these three things. So a doge could be just nothing, like space, right? Like zero string. I don't know how what's the right word. That is a doge. And one phrase would be an adjective followed by a noun. So this is something like lambda calculus. So a phrase is an adjective followed by a noun. I think in lambda calculus is like, yeah, this is so actually similar to it. Like an expression is one or more, I don't know how it's called. I think it's called variable is such and then a function is such and such, and an expression is a function. Yeah, I actually forgot that. Not use. Look at this. I think chat will know this. This is similar to how lambda calculus is defined with vars, variables, function, application, and an expression. Yeah, there's these three things. Yes, the way you define adjective, noun, phrase, and doge is indeed conceptually similar to how lambda calculus. So that's kind of like when you're not used to the functional paradigm. When you say, look at this, conceptually similar to how lambda calculus defined its syntax with variables, function, application, and expressions. So adjective, right? Wow, many so. Noun, Lisp, language, phrase, a combination. Okay, example of doge. Wow, Lisp, such book, or so language. So that's a phrase. Or you could say these are like three phrases, three doge. Yeah, these are actually three doge or dodge. The hierarchical structure is compositional, meaning you build complex expressions from simpler ones. And lambda calculus is variables represented by a single identifier, x or y, abstraction, a function definition like lambda x dot e, where e is an expression, which is x, y, or something. An application, a function applied to an argument like fa, where f is a function and a is an argument. So lambda x and lambda x, x, y, yeah, this will be hard to understand actually if you've never done this, because it goes inside, like this z goes here. No, this actually, no, it will be hard to actually understand this, yeah. I don't know if this will have adjective, noun, here variables, composition. Yeah, I was curious about, yeah, I don't have nix here. I can't show this lambda x. Yeah, but this would be interesting to compare, but maybe not now. I'm not sure how to do this. Semantic purpose, such Lisp. Yeah, not sure. Sorry. We can start by, that's the functional paradigm. We can start by trying to define adjective and noun. To do this, we create two new parsers represented by the type MPC parser underscore T star. I'm not sure if you really, how do you read these things? Like, do you really have to read them? Like star underscore. And we store them in variables, adjective and noun. I know how to make predicates and other callback. All right, but that's as far as I go. Well, that's it. Yeah, I mean that's the whole point. If you can move like that, just tells you it's a pointer. So right. Yeah, I still kind of read things and not just, I don't really see, I guess I need more time to see the meaning of what I'm reading. Ahoy hoy. And we store them in variables, adjective, and noun. We use the function MPC or to create a parser where one of several options should be used, and the function MPC sim to wrap our initial strings. If you squint, you could attempt to read the code as it were the rules we specified above. Right. What makes C++ different from other languages? That we can have variables that store the memory address of other variables. Yeah. Yeah, that's why I'm kind of doing it. Build that store the memory address of other variables. Build a parser adjective to recognize descriptions. So MPC parser. Yeah, it's so adjective is a pointer to the MPC, to this thing. Okay, MPC or for, and wow, many, so and such. Now the difference here is that this is like finite. We just have these 4 adjectives in our entire language, I guess. And build for noun to recognize Lisp, language, book, build C. So it can only know like 5 nouns, 1, 2, 3, 4, 5 nouns and 4 adjectives. So maybe we could build that could recognize hello world, like 1 noun and 1 adjective. A lot of other languages do this without you knowing, like references. How can I access these MPC functions to another variable, some container? For now, don't worry about compiling or running any of this sample code. Just focus on understanding the theory behind grammars. Well, in the next chapter, we'll get set up with MPC and use it for a language closer to our Lisp to define phrase. Well, I'd still like to type something, something more minimal. That's the nice thing with ChatGPT. You can make a very minimal example and kind of work through it. But books really can't do that. That would be too long. To define phrase, we can reference our existing parsers. We need to use the function MPC and specifies one thing is required than another. Oh, so this is the AND function, almost like a Boolean for a parser or what? MPC AND, for a phrase, right? So a phrase will have a adjective, noun, and a free. Why free? Is this again with the memory? As input, we pass it adjective and noun, our previously defined parsers. This function also takes the arguments MPCF string, is this string fold, and free, which says how to join or delete the results of these parsers. Yeah, before we had string length, string fold is, I guess string fold, the memory of an object, a container. I guess string fold is, so 2. But what's the 2? I guess adjective and noun and free and string fold. Maybe this string fold is connected with free. To define doge, now we'll have a doge, a phrase. But that's a phrase, right? We have one phrase here, so that's a doge. But we have to do the string fold here as well, and MPC many. To define doge, we must specify that 0 or more of some parser is required. So for this, we need to use the function MPC many. I see. As before, this function requires the special variable MPCF string fold to say how the results are joined together, which we can ignore. MPC parser. So doge is a pointer to this, and phrase is a pointer to this. So this is like what? This is like the same location, I guess. But phrase. And what did we have? A noun. A noun also points an adjective. So we have 4 of these jumps or what? So MPC. But so I guess this thing is defined then in the code. But I find it to reason about it same. Right. So by creating a parser that looks for 0 or more occurrences of another parser, an interesting thing has happened. Our Doge parser accepts input of any length. Oh, how come? Wait a second. Yeah, maybe because it can make combinations. This means its language is infinite. Here are just some examples of possible strings Doge. Yeah, it's infinite because it could accept all kinds of combinations, but I think it's finite. I thought it's finite because, well, we have 4 adjectives and 5 nouns. So potentially it's finite because how many combinations you can make with these? I don't know, like with 4 adjectives and 5 nouns. But it's infinite because it can be, yes, it's actually infinite. Just as we discovered in the first chapter, we have used a finite number of rewrite rules to create an infinite language. It is infinite because we can say it so many times, like, wow, book, such language, many Lisp. So see, such build, such language. So we can repeat them, right? And that makes it actually infinite. So you could have like 100 nouns and 100 adjectives, so you can make a very complicated kind of language. We don't have to worry about it in other regular languages. Wow, Lisp, wow, so many languages. So if we use more MPC functions, we can slowly build up parsers that parse more and more complicated languages. The code we use sort of reads like a grammar, but becomes much more messy with added complexity. Due to this, taking this approach isn't always an easy task. A whole set of helper functions that build on simple constructs to make frequent tasks easy are all documented on the MPC repository. This is a good approach for complicated languages as it allows for fine-grained control but won't be required for our needs. So natural grammars, all right. Now we're coming to something. So MPC lets us write grammars in a more natural form too. Rather than using C functions that look less like a grammar, we can specify the whole thing in one long string. When using this method, we don't have to worry about how to join or discard inputs with functions such as MPC, stringfold, or free. All of that is done automatically for us. So we don't have to worry about how to join or discard inputs. I don't know if this has to do with memory. Not sure. Here is how we could recreate the previous examples using this method. So, okay, now we have it. We had this before, but I guess this is defining it more higher level because we had, let's see, adjective code. Where is the adjective? Here. MPC parser adjective, and then we defined 4 words. But now we'll have it MPC new adjective. Noun, phrase, doge. MPC lang, MPC default. Oh no, okay, we just defined it here. I guess this is some kind of special way how you define a block of string or what? String code in C? Not sure. Adjective, noun, phrase, doge. Do some parsing here. MPC cleanup for adjective, noun, phrase, and doge. Okay, this is interesting. So without having an exact understanding of the syntax for that long string, it should be obvious how much clearer the grammar is in this format. If we learn what all the special symbols mean, we barely need to squint. Another thing to notice, again he says the word squint. Another thing to notice is that the process is now in 2 steps. First, we create and name several rules using MPC new. Yes, these are with rules with which we will create. I guess this will be used for the Lisp, I guess. Like we'll put like a function or maybe the terms in Lisp. Yeah, not sure, but this is how we will break down the Lisp the way we write Lisp and then to parse that. Another thing to notice is that the process is now in two steps. First, we create and name several rules using MPC new, and then we define them using MPC lang. The first argument to MPC lang are the options flags. For this, we just use the defaults. The second is the long multi-line string in C. Okay, that's the way how you write the multi-line string in C. We have to put these escape kind of, all right. But also here, it kind of looks complicated. A char star variable can refer to a memory block buffer created by malloc. However, that same variable can be assigned the memory address of another char variable by using the operator ampersand. Yes. So we have to pay much attention about the nature of a pointer variable. Yeah. We need types. Okay. Without having an exact understanding of the syntax option, with the first argument to MPC lang are the options flags. Options flags, right. For this, we just use the defaults. The second is a long multi-line string C. This is the grammar specification. It consists of a number of rewrite rules. Each rule has the name of the rule on the left, a colon. Each rule has the name of the rule on the left, a colon. All right, that's the name of the rule. Phrase and doge, right? Could make this even like bigger. Wow, many. So it's just, I was like, is this finite? It's kind of finite. This I don't know the right word, the right PL word. It's infinite, but it's a finite number of, you know, possible words. I guess you have to define it, right? We'll do that with Lisp. Lisp language book build. The second, and on right, its definition terminated with a semicolon. The special symbols used to define the rules on the right-hand side works as follows. AB. The string AB is required. The special many C. The string AB is required. What does this refer to? The special symbols used to define the rules on the right-hand side work as follows. The string AB is required. The rule ABA, ABBA is required. Oh, I see. Yeah, this may be a little confusing. Wait, adjective, noun, I see. It's using these kinds of, these brackets. What do you call them? These are not brackets. Forgot the name. And phrase, and this is a phrase star, as it can have more phrases. Right, right. So we have these thing here, and we have, this is like or. Lisp or this, or this or this. Yes, either A is required or B is required so that it satisfies, I guess, what the parser demands. The string AB is required, the character A is required, the first A is required, then B is required. Okay, so when we don't A and B, so this means that both are required. Okay, this is like and, but we don't have the and sign here. And this is or, either A is required or B is required. And 0 or more A's are required, and 1 or more A are required. Now this maybe even looks confusing, like 0 or more A's are required, 1 or more A's are required. It's like, what's the real difference between these two? Like 0 or more, like this may seem confusing, or like, It's not confusing, but it's just, I guess I want more context of this. It's not confusing at all. Once you get the hang of difference between 0 or more and 1 or more. 0 or more, this means the pattern can include not A at all. 1A, 2 or more A's. Okay, so it means it could be like an empty space or what? And this means the pattern must include. Okay, but why would I have, why would I have both defined? Because otherwise, like you could have like 0 or more. Having both my CPU is slow. Useful when the presence of A is optional. I see. This allows for patterns where A may appear any number of times, including not appearing at all. Useful when the presence of A is required at least once. This ensures the pattern always includes at least one A. Matching words, what's the practical example? So A star, again, A star is 0 or more A's are required, and A plus 1 or more A's are required. A star, 0 or more. So matches strings like empty string, right? That's what I thought. A or AA or AAA. So example, matching optional letters at the start of a word. A star dog matches dog, AADDOG. Oh, A plus matches strings like AAAAAA, but not empty string. Example, matching one or more A before dog. Pattern A plus dog, AA dog, AAAA dog. Does not match dog. But wait a second, is that just like the same thing, but one or more A's are required? It's funny, it's like this still does not click. 0 or more digits. Let's see this. Yeah, maybe it's easier with numbers. Empty string 1, 1, 2, 3, 1, 2, 3, 4, 5. Matching an optional numeric value in a string. Pattern 0 to 9 star. We have this also with pointers. We have a star. And that includes 0 or more, right? We don't have like char plus. We have char star. Matches meters, 1 meters, 1, 2, 3 meters. 0 through 9, 1 or more digits matches 1, 1, 2, 3, 1, 2, 3, 4, 5, but not empty string. Matching a required numeric value in a string. 1 meters, 1, 2, 3. Why keep them separate? Sometimes you want to match even if the value is optional. You want to ensure that it's at least one occurrence. Precision in matching. Always matches. AAA. It's kind of still not clear. It's funny. This is a nice explanation, but I guess defining both allows you to write patterns that handle optional content or enforce mandatory content. Enforcing, this makes kind of sense, optional and enforcing mandatory content. This distinction is particularly important in text processing, regex, and parsing. Let me know if you like examples from programming or regex. Yeah, I prefer this response, but I guess you never use, I guess you never use char plus, like in pointer plus. In C, char star defines a pointer to a char, and the plus symbol has a different meaning. It's an arithmetic operator for pointers. Okay, that's a different meaning. All right. One or more A's are required. So ABAA, the rule called ABBA is required. So B has to follow A, B has to follow B, A has to follow B. I guess this is what it means. Yes, sounds familiar. Did you notice that the description of what the input string to MPC lang should look like sounded like I was specifying a grammar? Yes, that's because it was. MPC uses itself internally to parse the input you gave it to MPC lang. I keep on thinking on Tron, the MCP. You know, in Tron, there is the MCP. I don't know if you guys know Tron, the movie Tron, the first one. It does it by specifying a grammar in code using the previous method. How neat is that? Okay, using the table described above, verify that what I've written above is equal to what we specified in code. This method of specifying a grammar is what we're going to use in the following chapters. It might seem overwhelming at first. Well, kind of, but I think it just needs... It's not so overwhelming. I think for me, I think I need to practice a bit, you know, write some more examples. Grammars can be difficult to understand. But as we continue, you will become much more familiar with how to create and edit them. This chapter is about theory, so if you're going to try some of the bonus tasks, don't worry too much about correctness. Thinking in the right mindset is more important. Feel free to invent symbols and notation for certain concepts to make them simpler to write down. Some of the bonus tasks also might require cyclic and recursive grammar structures, so don't worry if you have to use these. So let's go to Dodge Code C. And we have an example here. All right, Dodge Code C. So, right. So let's do a hello world MPC. A very simple one, even with less words. I just want to try something with less words even. So I'm going to, let me close this. Right. Oops, I removed the wrong one. What's the name? Dodge Code. Let's kill this also and open up a new one. Build your own Lisp. Dodge Code C. No, Dodge C. Why are you trying to learn a library called MPC? Oh, okay. So, well, I'm just trying to just understand a bit how the code works. I don't know, like this is the build your own Lisp, right? So in build your own Lisp, he's teaching kind of C while building an interpreter for Lisp. And one of the things that he didn't do is he didn't write from scratch the parser for it, and he included his own MPC library. But he will kind of implement that at the end of the book. At the end of the book, he will implement it MPC. This book is kind of similar to this. I don't know if you know this, crafting. This book is nice also. So here he's basically doing this from scratch. I kind of thought to do this too along this because the first part of the book, he does it in Java. He makes like a language called locks. And in the second part of the book, he does it in C. And he builds actually the whole thing from scratch. The difference between build your own Lisp is he already includes the MPC. MPC is the parser combinator library. So I'm kind of, I don't know, I'm not trying to learn it, I guess. I just want to write a hello world. I just want to type more of these things because I think it's important to just type these things, you know, and it sticks more when you do something, you know, like I kind of understand what he did here. But if I just skip back and forth, you know, if I just go to the next chapter, I'd just like to try it and compile it and maybe use not so many words. And yes, I would like to use this and maybe create some kind of maybe to use a while loop or like a for loop to create a random phrase generator that would combine some of these nouns and adjectives just to practice C. Yeah, I guess that's why. I hope that makes sense. Dodge C. So, but I will have to end probably in 20 minutes. I don't have much time. Dodge C, so I'm going to include standard OHH and include what he called it, MPCH. Oh, I thought it will be also with those brackets. It's not. Like, how does he? I have still no idea how to include third-party libraries in C. I don't get it. Like, what do you mean include MPCH? Where does it include it from? How does it know? Isn't it weird? I only had to type in make. That compiles my code based on a file called make. Yeah, that makes sense. But I understand like there is std bool h, right? And now I have the bools. I can do stuff with bools. But how do you do this? How do you include the MPCH? I think I would have to. No, I think I would have to have it. I would have to download it. I don't think this works. Does someone know? Will this thing work? No, it can't work, right? Right, int arg c char star star. MPCH is a file he created. I don't know the context, just join the stream, but that's how it works. Yeah, see, you get some. Yeah, I don't think it will work. Wait, let's dodge. Look at this grammar. So write down some more examples of strings the Doge language contains. Why are there backslashes? Describe textually, describe grammar. Maybe if I go to MPC, yeah, I'll do this. Build your own Lisp MPCH. But a third-party libraries need to be told to the compiler where they are located. Yeah, right? MPCH, right? MPC. So this is this thing what he did. So this is a micro parser combinator library for C. Daniel Holden. And this is the thing. This is the thing that he will actually show how to make at the end of the book. Useful parsers, but look at it. This is kind of even not so. It doesn't look too hard. Standard IO, arg math. So here is defining here. What are you trying to do? Oh, I'm going through the book, Build Your Own Lisp. And now I'm at the part of Build Your Own Lisp. So we are going to build. He's showing how to do C programming by building an interpreter for Lisp. So now we were studying grammars, and this is what he showed. And he included here at the beginning, he included the MPC, his own, where is it? His own micro parser combinator library for C, which he will recreate at the end of the book. So that's the goal of the book. Build your own Lisp. I don't know if you heard for that book. It's kind of similar to this one, crafting interpreters. So here there's a struct. Yeah, but maybe if I go to Build Your Own Lisp, MPC, chapter 6. Maybe I have to download it. Yeah, I'm not sure. storing is easy. Enums. Oh, this is a long code actually. Okay, maybe I'll move on to the next chapter. An H file is merely a description. We need the C file for the actual implementation. Yeah. Maybe I'll write down some more examples of string. Maybe I'll see what's actually in the next chapter. And then come back to 5. So each H has to have a corresponding C file. Okay. I'll go to the next chapter and maybe then come back and do those practices. Okay, installing MPC. Look at this. Before we work on writing this grammar, we first need to include the MPC headers and then link to the MPC library, just as we did for edit line. So starting with your code from chapter 4, you can rename the file to parsing.c and download MPC H and C. Yes, I have to download them from the MPC repository. Orange Duck MPC. Yeah, it's here actually. A parser combinator library for C. Lightweight and powerful parser combinator. Features. Quick start. Here is how one would use MPC to create a parser. Yeah, okay. Well, I guess I'll read now from the chapter from where he starts here. It's quickly down below. So to try out MPC, we are going to implement a simple grammar that resembles a mathematical subset of our Lisp. Oh, now he starts with Lisp a bit. It's called Polish notation. And it's notation for arithmetic where the operator comes before the operands. This is kind of cool, yeah. For example, 1 plus 2 plus 6. An object file is enough with all the symbols though. All right, is it because the object files then splits into kind of contains, I don't know what's the right word, it contains the header file and the C file? No, yeah, because you write the C file and the headers file, I guess, and when you compile that, you get the O file, which is kind of has both. But I guess you wouldn't share that, right? And then extract both from the O file? No, I mean instead of a C file. Yeah, the O file is the compiled code. Yeah. Is that the right term to say is the compiled code? No, yeah, it's the compiled code. The executable code is the next step, I guess. I was just wondering is that the right term. We combine H and C to get O. Yeah, we combine it. To try out MPC, we're going to implement, okay, 1 plus 2 plus 6 is plus 1 to 6. I really like this. Yeah, but anyway, 6 plus 2 times 9 is plus 6 times 9, 2. And this is, yeah, okay. So we need to work out compile code that was not proper. Oh, it's linked. Yeah, right. I forgot that. Linked, map to memory. It's compile code that is still not linked without the linker, I guess. Yeah, okay. Okay. I mean, it makes, I probably said it wrong again. We need to work out a grammar which describes this notation. We can begin by describing it textually and then later formalize our thoughts. So what do we have here? Well, it's almost like verb and a noun. Like this is a noun, verb, like verb as in add this or some. Noun, verb, noun, and this is verb, noun, noun. And that's the rule, no? Okay, to start, we observe that in Polish notation, by the way, I think this is Rembrandt. Is this Rembrandt? It looks like Rembrandt. It totally looks like Rembrandt, a Polish nobleman, a typical Polish notation user. Maybe this looks like someone who would use Lisp or Haskell. I guess out is similar to O. You cannot reverse O file to H. All the struct union type def information is absent. Oh, of course. Oh, yeah. Yeah. Is absolutely lost. Okay. We need to work out a grammar which describes this notation. We can begin by describing it textually. Okay, to start, we observe that in Polish notation, the operator, right, always comes first in the expression. Operator comes before the operands. He didn't say this, but yeah, this is the operator plus, and 1, 2, 6 are the operands. Always comes first in an expression. Yes, an operator and operands make an expression, followed by either numbers or other expressions in parentheses. Why he isn't saying operands? Maybe that makes sense. This means we can say a program is an operator followed by one or more expressions, where an expression is either a number or in parentheses an operator followed by one or more expressions. Okay, I have to read this again. A program is an operator. Why is a program an operator? A program is an operator followed by one or more expressions. Because when I read this, it sounds like a program is plus followed by one or more plus somethings, where an expression is. So I maybe, okay, this definition looks recursive, where an expression is either a number or, in parentheses, an operator followed by one or more expressions. This sounds like a definition of a list. More formally, program, the start of input, an operator, one or more expressions, and the end of input. It's kind of like the formal description sounds simpler than this. Wait a sec, is this recursive? It is. So that I can see it better. Is this recursive? Yeah. Yes, this definition is recursive because an expression can contain other expressions, potentially nested indefinitely. Well, I didn't see any O command make just output. Make deletes all intermediate files automatically. Oh, okay. Let's format it to make the structure clearer, show how it's recursive. A program is, and now go inside, an operator followed by one or more expressions. An expression is either a number, 1, 4, or an operator, or the program. It's just confusing, I think, to use this, followed by one or more expressions enclosed in parentheses. The operator plus. The expressions are 1, 2, 3. So, yes, you could do it like this. Now let's see a recursive example where expressions contain nested expressions. That's the top level. 1, a nested expression. Operators become nodes and expressions become branches and leaves. Yeah. Okay. Okay, let's see further. Expression, either a number or beginning of parentheses and operator, one or more expression, and the end. So we have to put the beginning and the end of it. Operator is what? Plus, minus, star, or divided. So I guess this is building just a kind of calculator of sorts. Not so much, yeah, so that we can at least add numbers and do all of these operations. An optional minus and add one or more characters between 0 and 9. Right, regular expressions. We should be able to encode most of the above rules using things we know already. but number and program might pose some trouble. Number and program. They contain a couple of constructs we've not learned how to express yet. We don't know how to express the start or the end of input. That's true. Optional characters or range of characters. These can be expressed, but they require something called regular expressions. Regular expressions are a way of writing grammars for small sections of text, such as words or numbers. Grammars written using regular expressions can consist of multiple rules, but they do give precise and concise control over what is matched and what isn't. Here are some basic rules for writing regular expressions. A really cool, I would like to share this because it's really nice. If someone wants to look, she has a really nice chat. What is this? OED 5? Is it OED 5? She has a really nice video on parsing. My CPU is really slow when I stream. No, I won't find it. OED 5. Is it called parsing? She has a really nice channel. I think it's kind of functional parsing. There are actually many videos, yeah. This is so slow. No, this is terribly slow. Efficient parsing. Look at this parsing. I think her name is K. Can I write K? Will that be enough? Parser in TypeScript. K-Lac. This is really nice, and she has a nice. Oh my God. Oh. Look at this. Ah. Share. Horrible. Yeah, I don't know what's going on. This thing is really cool. It's a really nice channel. Really nice. Really. And she also goes from yeah, he or she explains actually what I was reading now. Yeah, it's really cool. I have to see this again. All right, I'll get back to this. Here's some basic rules for writing regular expressions. Okay, here he just shows. I kind of know this thing. I don't know. Like a dot, any character is required. This kind of like, if you want to create a file, you write a dot. Any character is required. The character A is required. A, B, C, D, F, any character in the set. It's like when you find stuff on, you know, Linux command line. Any range, or you delete something like that has a 0 or more are required. That's kind of cool. Like if you say couple of, if you just want to delete the files, if you have many files, and let's say you want to delete the files that start with an A, but they are not the same word. So you write A star, and then it will delete every file. If you want to remove a file that begins with the letter A, yeah. These are all the regular expression rules we need for now. Whole books have been written on learning regular expressions. I guess the dot means it needs a character at that place. It can be any character. But you know, like when you, let's say you open up, wait. Let's say I'm ls. Look at this. If I write vim dot, error pertained. Oh, I don't have it. Wait a second. Yeah, let's do. What did it happen like this with Helix? Like, what did it do when I pressed dot? I don't know. Or if I just open it up like this, hx dot. I think it runs all the files. Look at this. It's like a fuzzy finder. Yeah, with the dot you open up everything. Yeah, I forgot my Linux. Yeah. Yeah, but I will check that. Yeah. Okay. In MPC grammar, we write expressions by putting them between forward slashes. That was the slashes thing. Okay. Using the above guide, our number rule can be expressed as a regular expression using the string this. And now we are coming to the part installing MPC. So before we work on writing this grammar, we first need to include the MPC headers and then link to the MPC library. Yes, we have to include the and then link to the MPC, just as we did for edit line. That was before in the third, I think in the third chapter or fourth. Starting with your code from chapter 4, you can rename the file to parsing.c and download MPC-H and MPC-C from the MPC. Oh, okay, wait a second. Ej, ok, onda ću se ja spremit već, a? Koja kutija sa robom? A, hoćemo je gore staviti. Da, da, ok. Kad ćeš doći? Dobro, ajde ću se ja sad spremit, ću ovo završiti. Ajde, čao. Ciao. I gotta go. Thanks, guys. So I'll just continue this next time. It's all right. Bye bye. Bye bye. Okay, stop streaming. Thanks, bye.